sing a happy song together, and we'll all be a happy family.
Hi, welcome back to the channel. So, this tape recorder, the TK10, Grundig TK10. Well, mine of course isn't a TK10, mine's a TK12. But the only diagrams I've been able to find are labelled for the TK10. Language is German, but we needn't worry too much about this at this stage because what I'm going to be looking at is just the power supply section, which is in this area here. What's shown on this diagram are the various valves or tubes, that being the level indicator, and in this area here there are two bridge rectifiers, but unfortunately they're both selenium ones and well past their sell-by date now, so really we can't trust them anymore. And not shown on this drawing here, but either side of these there are capacitors as well. So that's basically where we are, the power supply section, because until we get the power supply working we can't do anything else. Now it happens that I've got two circuit diagrams. One is all on one page, which is this one, but it's drawn differently to another one. I've only got half of it here, but there is another half to this, which is the same circuit. This power supply is the same circuit, drawn very differently. So what I've done is enlarged just those parts of the two drawings. So it's quite interesting actually that this one, the transformer primary, is shown more or less the same. The secondary, it's shown everything the other way up. But one is clearer than the other, but it's nice to have the two, because when I look at this one here, there are 4 filter caps there. There, and there. And on this one, at first glance, I can only see 3. But it turns out that the other one is up here. But when you trace it back, you can work out it's connected to this line. So the ease of this, we'll just look at this one for now. And we have the 2 rectifiers. We have sort of pi filters on both of them. I'm not sure about this yet, I'll have to look into that more closely. But yeah, this is a simple pi filter here anyway. I'm sure it's the same sort of thing. Now we've got 2 voltages, obviously, because we've got effectively two power supplies, ignoring these feeding the bulb filament and so on. So we got stated here 223 volts. On the other one, it just says 223.30 milliamps. Underneath it's got something printed here, which presumably one will be when it's in play mode and one is when it's in record mode or something like that, but it states 2 different currents there and therefore a slightly lower voltage and a slightly higher current. But from that point of view, it's easier to look at the top drawing just for the voltage side. 223 volts there, and the low voltage size is 25 volts at 140 milliamps. So a few things came to mind straight away. One thing would be I would replace these with silicon diodes, and the 1N4007s will probably do for that, because this one's fused at half an amp and the 1N4007s are good up, I think, to 1 amp. They're well within the voltage range, so there's no problem there. So really all I need to use is 8 1N4007s to replace both of these. And the capacitors, well, this is being the low voltage side. There's 100 microfarads. Oh no, they're both 200, so I'll correct myself there. They're both 200 microfarads, but this isn't very clear. At 35 volts, so we can use two 220s in there for the 24 volt or 25 volt line. This one, there's 240s, so I'll be using 247s, because I don't think it will matter that they're a bit higher, because these weren't very close tolerance anyway, the original, so they could have even been 47s originally or more. So I use 247s there, and they've got to be rated. I think I've got 400 volt ones. This is 380 volts, so I should have those, and I should have the diodes. Well, I know I've got the diodes, so that resistor, we can obviously use the one that's there, or increase the value of that resistor to compensate for the higher voltage from the silicon. That might be an option there. I'm not sure about this at the moment. If we're looking at the 25 volt one, on here it's shown there. I'm not quite sure about that component there, so I'll have to look a bit more at the data on that. But effectively, yeah, it's rebuilding pretty much all of this, apart from perhaps these two. Definitely it would be an advantage to change this to suit the more efficient rectifier, and I'm sure something could be done here. We'll probably have to put a resistor in between here and here, because it's taking a tapping off of there and another one off of there. Now, one thing that occurs to me, certainly with the low voltage size, is it says 25 volts there. It turns out that I've got 24 volt regulator chips, which are good to 1 amp, so these are well below that. So I could, if I didn't mind having 24 volts instead of 25 there, I could just put a regulator in there as well, which would get round the problem of the higher voltage going in, as long as the voltage here isn't above the level that the regulator can cope with. Again, I can stick a resistor in there anyway to bring it down a bit, which I probably will. So certainly that side I could consider using a voltage regulator when I'll end up with 24 volts rather than 25. I wouldn't have thought that would make too much difference. On this side, change that resistor will get me the voltage correction for here. So what I could do is just replace the diodes and the capacitors, bring it up slowly on a variac, see what voltages I actually get, and then calculate from this what sort of dropping resistor I'd need. So that's the plan of action, is to get the power supply working and giving me around 225 volts and around 25 volts are the two voltages that I need to achieve. So just a quick look at where these parts are on the actual machine. Use out the way. So here we Now, as we can see, if I try and hold that fairly steady, these are the power supply components here. So, lifting up a bit more, we have these capacitors, 2 there and 2 there, and these are the bridge rectifiers that are selenium ones. There's the metal one there, which I think is the higher voltage one, and the other one for the lower voltage there. Or there may be the other way around, but those are the 2 rectifiers there. So really it's all this area here, and it might be worth me thinking about, do I simply redesign a layout for this to take the modern components, since none of these original parts will be any good. So I think I've got the components already. I think I can look carefully at the wiring here and carefully label it up so that I make sure I get the correct transformer windings wired to the correct ones. Out of interest, when I've taken this apart, we'll test these, see what sort of condition these capacitors are in after 70 years. I don't intend to do anything with these selenium rectifiers. I'll just remove them and replace them with the diodes. And of course, the diodes take up very little room compared to these. Capacitors will be smaller, so I'd imagine this area here will be smaller and neater, hopefully. So that's the plan of approach anyway. We get the power supply right and get the correct voltages, even if we have to run it with the variac, so that we put in a lower voltage to start with. We can monitor the voltages out of these, and then start looking at the rest of it. Once I've got the correct voltages, before I apply any power to it from here, I will need to address the capacitors, some of which have broken, and most of them probably will be very questionable as to whether they're any good. I'm hoping I won't have to change resistors, especially these big sort of ones here. We hopefully can use those again. And of course those components underneath, which I showed in an earlier video, which look really crusty, most of them are probably going to have to be changed. So yeah, there will be more work after I get the power supply going to actually address some of those issues. Once things will power up, then I can start thinking about giving it a try and just seeing if it will actually run. I don't anticipate too much trouble with it, but you never know. Things always have a way of throwing more problems at you that you never foresaw, so we'll see how it goes. But for now, that's the plan, and I won't go into videoing taking all this apart and so on, because I need to concentrate really on what I'm doing and making sure I don't make mistakes, especially with the voltage side. And then I'll get back and show what I've done and how it looks. So yeah, that's it for now, and I thank you for watching, and we'll catch you on the next one, and bye for now.
Sing a happy song together, fill the air with harmony. Sing a happy song together, that's the song to choose. For pushing away the blues, keep the heartstrings running, there's a good time coming, if we keep on humming.